Hello friends, welcome back to my channel. Let's learn. So today I'm going to discuss here one POC that I have created about RAG, that is Retrieval Augmented Generated AI, and this one I have created by using Hugging Face GenAI model. And here basically I'm going to discuss it here, that how simply we can utilize any Gen AI model to provide the information about the using the context that we are providing. For example, if we are using OpenAI chatbot, ChatGPT or Gemini, then it provides the informations or answers of our queries not on the basis of our context. It is having the pre trained model, and based on that it is providing the data. But we can programmatically we can provide our context to these kind of Gen AI model, and then whatever questions we are asking, then these Gen AI model will provide the answers from that context. So for that, what are all the things we required? So here I'm just telling what are all the things are required to be used, that has been used in making this application. So first I have used Python 3.10.0, and then I have used Hugging Face GenAI, and I have used Hugging Face because it is free for much longer period compared to Gemini or OpenAI, and it has some limit of monthly uses, some token limit of monthly uses. But again, once that limit is consumed, it will not allow you to further use for that month only, but again next month you will be able to use. So that is the benefit of using the Hugging Face. So in Hugging Face I am using two model. One is the LLM model, and another one is the embedding model. So why I am using embedding model, I will let you know. So this is Hugging Face, and next I have used one special kind of DB, that is the vector DB. So why I have used vector DB, that I will also inform you. So under vector DB there are several types of the vector DB. So I have used Chroma DB here. There are other DBs also, you can use other DBs also. I have used Chroma DB, and so these important things we need to use. And along with this also I have used basically the Flask library to create a server, so that I can expose some APIs, and those APIs can be triggered from some UI. So this is basically the API part that I have created. This is basically the API part, and one UI part also I have created. That UI part is basically created in React. So here UI is where user there are two kinds of the user that I will discuss, and those users can provide the context, can ask the queries. So those I will give the demo. So this is the prime technical requirements that we need to have before starting working on this application. And one more thing, when you are using the Hugging Face, then you need Hugging Face API token. So for that you will have to register in Hugging Face. You do not need to provide any payment method. You just need to register there, and then you can create your API token. Those API token will be used while interacting with the LLM or embedding models. So now I'm first going to discuss the design that I have used in creating this application. So basically here you can see this application is having the two part. One is the user interface and another is the API. API is basically the server side, and user interface I have mentioned it's a UI part that I have developed in using the React. So in UI, first user is coming on the landing page is basically the login page where user can log in, and there are two types of the user here. One user is admin, another user is the customer. So admin is having more privileges, so admin can use these four components. One is the upload document, another is the list document, then third one is the delete document, and fourth one is the query component. So these four components admin can use, and customer can use only one component, that is the query. So customer can just query, he will put some query and he will get the answer. He will not be able to upload the files, he will not be able to list the files, he will not be able to delete the uploaded files. Now what is the purpose of these uploading of the files? So basically whatever the files we are uploading as an admin, those files are basically creating the context, and whenever we are asking any questions, then our LLM is providing answer from that context, from the context that has been created by these files. Means whatever the informations are available in these files, the LLM provides answers based on that uh, information only. So now let's see how these are interacting with the server side. So first one, when admin is trying to upload any document, then on the API side it is triggering this upload API. Now what upload API is performing? So upload API is basically performing three tasks. So first task is that it is reading that uploaded files, and it is saving that uploaded file in a folder. I have named it as uploaded docs. So in this folder it is uploading, it is just saving that file. This is the task one. Under task two, what it is doing, that it is reading the text from that file. Okay, and after reading the text, it is dividing the text into the multiple chunks, and then each chunks it is sending to the Hugging Face embedding model. So if you remember, I had told you that I am using two model. One is the LLM model and another one is the embedding model. So first the chunks of text data we are sending to the embedding model, and then embedding model is converting that text data into the vector data. Vector data is nothing but it's a kind of numerical data, it's a kind of mathematical data. Means it's convert your text like ABCD in terms of 0 1 2 3, these kind of mathematical data it converts, and those mathematical data are basically called as a vector data. So this embedding model is basically converting the chunks of text into the mathematical data, that is the vector data, and those vector data are coming to coming back to our API. And then in third task, what it is doing, that it is collecting all the vector data for each chunks, text chunks, and then it is saving those vector data in vector DB. So this is these three tasks are being performed when user is clicking on the upload. Now when admin is trying to see that okay, how many files I have listed, then files I have uploaded, then he will click on the list, and then it will trigger the slash files API, and it is not doing anything much. It is just going and reading all the file names from the this uploaded doc folder and sending the list of the names to the UI. Now when admin is clicking on the delete, means if admin is trying to delete any file, then it is triggering this API, that is slash file name, and then it is also performing multiple tasks. So first task is that it is going to this uploaded folder, and from this uploaded folder it is finding that particular file name and it is deleting this file name. So this file name is deleted, but here task is not done because it's this file had created, while uploading this file it had created some vector data, and those vector data we had saved it here in the vector db. So if file is deleted, then we need to delete those vector data also. So what it will do, that it will take the file name, and one thing I forgot to mention here, that while we were saving the vector data in this vector db, that time we were keeping the file name as a metadata, so that by using the file name metadata we would be able to find all the vector data that are related to a particular file name. So for example, if suppose there is a file name, say abc.doc. So here we suppose we created 5 chunks of vector data, and all the 5 chunks of vector data are saved in under the vector db, and with the file name abc.doc as a metadata. Now this abc.doc is deleted from here, so we need to find all the 5 chunks of vector data that has been saved here, so that it is trying to find in the task 2 by using the file name as a metadata, and when it is finding those vector data, then it is deleting those vector data, so that vector data will not be available in our vector db. So the context with respect to this file will be deleted, and our uh, API would not be give the answers if any questions comes regarding this file. So these all tasks it is doing in the delete doc. Now when admin or customer, any one of these is putting some query under the query component, then what is happening, then it is triggering the query API. And what query API is doing, that query API is first whatever the query text query has come, for example, what is my name, so this is a text has come, so it will send this text to the embedding model, and it will find the vector data with respect to this text query. So it will get some vector data, some mathematical data. Now what it will do, that it will take that vector data and it will pass those vector data to the vector db, and it will try to find that what are all vector data that are stored in vector db that are nearly matching with these vector data that we have got from embedding model with respect to the query. So it will try to find the nearly matching vector data from the vector db. Here the match will not be the exact match like we do in the SQL DB or no SQL DB. So it's not like that. It's a kind of cosine comparison where it will find the nearly match. I mean, what are all vector data that are very much near to this vector data. So it will try to find all those vector data, and then once it will find a few vector data, then it will send those few vector data to the LLM model, and then LLM model will process those vector data, and it will return the response. It will return the text response from those vector data. So what vector data, from where, what vector data we are providing, so we are providing the vector data that has been generated from our uploaded files. Okay, and LLM is returning the text representation of those vector data only, so it is finally giving answer from the file whatever we have provided. So this is the overall design here that I wanted to explain. If you have any query or if you have any confusion, you can post in the comment box, and I will be happy to answer that. Now I'm going to demo it a bit, so that you will get you can correlate this design with what is happening really in the application. So let me give a demo. So this is as I've told you, I have created one UI page. This is the UI page, and this is my landing page. So here I'm just first log in as a admin. So admin, and I'm giving a password. I'm selecting your admin, and then I'm clicking on submit. So if I'm clicked on submit, here it is showing Jeet admin, and what is my role? My role is admin. And here I'm seeing the three components. One is the query component. This component is common for both admin and normal user. And I'm able to see two more components. That is, one component is upload document. So this component will be available only to the admin. Only admin can upload the files. And another is this component. Here we are showing the list of uploaded document, and admin would be able to delete the document from here also. So these two components are available to admin only. Now let's upload a file. So for that, first we will have to choose a file. So I'm just choosing one file, and this is my rental agreement file, and I'm clicking on the upload. It will take few seconds to upload. So it is performing all those work that I have mentioned. It is creating the embedded data, and it is saving those embedded data into our vector DB. So if you see, this file has uploaded and it has come here, the rental agreement. Now if I am saying that um, suppose what is the suppose I'm saying that how much rent the how much rent I am paying monthly. Let's see what response it is giving. So see, it is giving the response from my document. Okay, so it has given me the response, how much rent I'm paying and how much is the percentage increase every month. Now similarly I can upload another document also. So let me upload another document, and this is a kind of my resume, so that I am uploading here. So again it is creating embedded data with respect to this file and saving it into the vector DB. So all these are done. Now if I am asking questions from my resume, then let's see in which city I am living now. Let's see, because in my resume I should have written this. So it is giving this information, and I think it is giving information from the rental agreement. Let's see uh, what is my current project in my current company. So this information will definitely come from my CV. So it is giving these informations. Okay, now suppose if I am deleting my CV information, so this CV information I have deleted, so that means it has deleted the corresponding vector data also. Now in that case, if I am searching, then let's see what it is giving the answer. So now, as the vector data with respect to my CV has been deleted, because I have deleted the file itself, so you can see that it is not able to find the context, and it is giving the answer that based on the provided context there is no information about your current project in your current company. The context only indicates the details about the rent agreements, because it is just finding the vector data of this rent agreement. So, and if I am deleting this also, and then if I am finding, then it is just saying that there is no relevant document find in your query. Similarly, let's upload. Let me show you the how user is behaving, what normal user is doing, what he is capable of doing. So let's upload a file here, because a normal user will not have this access of this component. So now I am logging as a user password. I am giving your customer. So here if you see those components are not coming, and here only query component is coming. And if he is answer asking, then again we have uploaded the rental agreement, so it is not able to give the answer. And if I am saying that okay, what is my current address, then it will give that information. So it will be able to give that informations. So this is the demo of this application. Now let me go through a bit in the code so that you will get more idea. So let me show you the code. Let me increase the font size. Okay. So this is my application, and the entry point of this application is basically the run. And here I'm not doing anything here, I'm just starting the server. And then all the routes I have basically defined here. And if you see control is, if I am clicking on upload document, and then it is triggering this API, that is the upload post method, and control is coming here and it is reading the files. Okay. And then those files it is saving here in the file path, and after that it is creating here the chunks from the first, then it is reading the text from this file. it so reading text is simple Python code. Here there is no LLM till now. So if you see here, it is simple Python code. It is reading the file, extract text from the file. This is also a simple Python code. So based on the extension, different functions I am calling. And if you see here, it is also normal Python code. So what is happening, so till here I'm getting the text from the uploaded file, and then here from here our models is coming into the play. So whatever the text we have read from the uploaded files, those text I am passing here in the process document. And then in the process document, first I will divide these text into the multiple chunks. So if you see here, I am dividing those into the chunks. If you see here, it is the split text I am calling. If you see, this is the split text, and here I am dividing it into the chunks of 50 500 KB. So this is the size of each of my chunks. So this is basically called as the fixed size chunks. There are multiple ways, 4 or 5 ways of dividing your text into the chunks. So for this demo purpose I have used the fixed size chunks. There are other ways of also chunking. So if you can go through here, you will get that 5 level of chunking strategies are there. So if you see here, level 1 is the fixed size chunking that I have used for my demo purpose, and another are like recursive chunking, then document based chunking, semantic chunking, and agentic chunking. So there are multiple ways of chunking. I have used the fixed size chunking. You can use any other ways of chunking. So chunking means just dividing your text, big text, into the small chunks of text data. Now after that what I am doing, that suppose I got here 5 chunks. For example, this is the chunks array. So in this array, suppose I have got the 5 chunks of text data. Now I'm passing these chunks and file name into this function. This function is basically what it is doing. This function will take these text chunks, and it will pass those text chunks to the embedded model, Hugging Face embedding model, and then embedding model will provide the vector data of each chunk, and then those vector data we will save into the vector DB. So if you come here, here get embedding this, we are passing here the text, we have put this array into the loop and for each iteration, whatever the text we are getting, we are passing that text to this function. This function is basically hitting the Hugging Face embedding model, and then this embedding model is basically returning the vector data, embedding data, and then we are getting those embedding data into an array. So for suppose if it is having the 5 chunks, then we are getting here the array of 5 set of vector data. Now those vector data we are saving into the our vector DB. So if you see these collections we have created above, here we have created client is equal to Chroma DB, and I have mentioned that I have used Chroma DB as a vector DB. So here I have created initialized this Chroma DB, and here I have got its object, collection object, and then here I am saving these documents here, and I am using the file name as a metadata, as I had mentioned you here. So this metadata will help me while I am deleting the file, so that I can delete the all the related vector data from this Chroma DB. So this is how we are saving our data into the vector DB, and this is all we are doing while uploading the files. Now while deleting the files, what we are doing, so this is query document list file. As I have mentioned, we are not doing anything much here, we are just reading the file names from our uploaded folders. So this is basically our uploaded folder. So this is basically under data, under upload, we are uploading our files. So here I am reading all the file name and just returning it in the list file, and this is basically the Chroma DB folder. Under this, whatever the chunks data is coming, those chunks data are being saved here. So these are not human readable data, these are basically utilized on the LLM side, and for cosine comparison. Now this is the delete file. So again, delete file, what we are doing, we are first deleting the document from our folder. So if you see here, we are just finding not this one. So here if you see, we are just file path we have got, and from here we have got the file path, and this file path we are unlinking means we are deleting this file. And before deleting this file, what we are doing, we are deleting its vector data. So what we are doing, we are passing here the file name in this function, and in this function what we are doing, that we are writing a query to find all the vector data where file name is equal to this file name, to get all the vector data related with this file. And then suppose we have got these vector datas, so we are deleting this vector data here. And if this flag we are returning that all the vector data has been deleted, if all this vector data is deleted, then we are deleting the files. So this is what we are doing while deleting the vector data. Now what we are doing while querying, when a user or admin is putting some query, then what is happening? In that case, control is coming on this route, query route, and then whatever the text query is there, suppose what is tenant name, so this kind of query is coming, so those query is coming here, text query. Then this text query we are converting that text query into the embedded model. So all these things are happening into the answer query. Let's go to the answer query, what is happening here. So here first we are doing that, we are finding the similar query, similar documents. So we are just let's see what is happening here. So here first we are finding all the files, uploaded file names we are finding. So these file names are the same names that are present here, all the files that are present under the upload folders. So these file names we are finding just to verify that we whatever the file names are available in our list, we are getting data from that file names only. So these are the just file names, and if file files are zero, means if there is no such file available, then from here only we are returning that okay, we don't have anything, any response to return you, and from here only we are returning. But if it is having some length, that means some file is there. Some file is there means some vector data will be available in our vector db. So we are moving ahead, and then we are passing this text query to the Hugging Face model to get its vector data. So if you see here again, we are just hitting the Hugging Face model, and we are passing our text here, and we are getting the corresponding vector data. This query now converted to the vector data. Now we are passing this vector data to the vector db, that is the Chroma DB, and we are doing the cosine comparison. Means this vector db basically does the cosine comparison to return the similar vector data. So these similar vector data, list of vector data are coming here. Now so these vector data is coming, and then those vector data we are uh, appending to make a single string of vector data, not the text data. And then here we have written a very small prompt that answer the concisely based on the given context. And what is the context? So context question, where is my question, and here we have given the context. This context we are passing here, and all these things we are passing to our LLM model, and LLM model will give the answer with respect to this context only. So here if you see all these things are coming as a prompt, and these prompts we have written one system prompt and one user prompt. System prompt, in system prompt we are saying that you are a personal assistant specialized in providing well formatted answers from the content being provided. And here we have provided the prompt, and we are hitting the Hugging Face LLM model, and we have given here the max token is equal to 200, and we have kept the temperature value very low so that it will not hallucinate, and it will give the almost correct answer. Although in case of LLM it's not 100% guaranteed that it will give the correct answer, but if we are keeping the temperature value low, then it will give there is a very high chance that it will give the correct answer, it will not hallucinate. And then it is triggering here, and we are getting the results. From results we are fetching the content, and this content is basically the text, and this text is being returned here. So finally it will come into the route, and whatever the answer we are getting, that answer we are passing here in the response. So that's how this application is working. So I could have write here each line while demoing, but that would have taken a lot of time. So to save the time, I have created it, properly run it, and then I thought to show here. So this is all here that I thought to discuss with you and try to show you that how easy it is to create a, RAG based RAG based chat model by using the Hugging Face LLM. And I will upload all these code in my GitHub account, And if anyone needs this link of this code, then please ping in the chat box, please ping in the comment section in the YouTube video in my channel, and I will provide you the link of this code, so that you can do some hands-on and it will be helpful for you. If it looks good to you, then please like my video, share with your friends, and that's all for today. Thank you.